So yesterday we were introduced to single-step equations. We understood the foundations of what makes an equation, what does it do to an equation. Question mark. What do we do to an equation? Solve. And the process of solving is synonymous with what are we doing when we're actually solving? Isolating. Not one person could answer that for me last period. So this was already on your notes yesterday. This is a repeat. It's literally copy and paste. The way textbooks would tell you to isolate the variable now when there's more than one step that you have to cancel, like more than one operation to cancel, is you're supposed to go reverse order of operations instead of PEMDAS SAD method. Look to cancel adding and subtracting first, then multiplication and division, then exponents and parentheses. But if that's your entire basis for solving equations, that could get confusing. I'll show you some examples of where that would be confusing. So a less formal way of teaching it, Dane, the board's up here, would be to work your way outside in. Look to cancel what's further away from the variable and work your way in towards the variable. So I would like to isolate the variable. Let's talk about the what, the when, and the how. Elizabeth, in order for the variable to be by itself, what would I have to cancel out? So I didn't say first. We're not going to go in order. Just tell me what. What do I want to cancel? The 3 and the -4, yes. Okay, the 3 and the -4. Sam, then we'll go to the when. When should I get rid of each one? Or better yet, let me rephrase. Which one should I get rid of first, the 3 or the -4? 4. Good. Why? Well, because you could say, hey, I'm going reverse order of operations. That -4, the reason why we're calling it a -4 is because it's the same as subtracting a 4. And the 3 is doing multiplication. And if I go backwards PEMDAS, am I canceling subtraction first or multiplication first? Subtraction. So what would be the opposite of subtracting 4? Adding. Where? Where am I going to add 4?
To both sides.
Both sides. So I get 3n is equal to 15. Last step is to divide both sides by 3, just like we would have yesterday. And then n equals 5. Not that I'm advocating for you to do this. I know it can be time consuming, but if you do feel more comfortable doing it, if you want to check your answer, any solution to an equation, up here n was a mystery. I didn't know what n was. But by working backwards, I was able to figure out what n was. Now that I know what n is, I can always get this n and plug it back up into the original equation, and I still should be able to maintain a statement of equality. 3 times 5 is?
15.
15 minus 4 is?
11.
Suna, give me the what. In order for the y to be isolated, what would I need to cancel? A 2, okay. And a 5. Bryce, give me the when. In order for the y to be by itself, just tell me which one should I get rid of first. 5. No. What basis would you base, like what would you claim? What would be the reasoning for that? For getting rid of the 5 first? What's your rationale? Just guessing. Yeah, Myra.
What? The 2.
And what would be your rationale for getting rid of the 2 first? Like, give me a reason. Like, other than just, like, what would be your reason for wanting to get rid of the 2 first?
Because you have by
Okay, well that's true, but it's not a reason. Like it's not answering the question. It's not a reason for getting rid of it. You want to answer, Coda? We're debating which number we should cancel first for the y to be by itself. Bryce says 5, Myra says 2, but none of them have been able to support their response.
because subtraction backwards.
Let Coda. It's Coda.
I know.
But
Because addition and subtraction add 4.
if you're going backwards order of operations, we would cancel out adding first by subtracting 2. Then we cancel out division by multiplying. So we end up with y is negative 50. It should tell you the classroom on the pass. No questions so far? And this is where the confusion sets in. So here you go, Ashley, Miss Show Off.
Huh?
Fancy
Show
pants.
off.
Fancy pants. In order for the y to be isolated, what would we need to cancel out?
The 4.
Okay, the negative 4, Ashley, and the 2. So based on what we know, which one would you want to cancel first?
4.
You would say the negative 4, right, Ashley?
Yes.
I think Brian wants me to call him Ashley.
You should call me Ashley now.
Be an improvement. Here's where math throws in a monkey wrench, right? Because you're like, hey, Mr. Romero, you said that subtraction gets canceled before division.
Yeah.
Well, see, in any fraction, see the difference with this subtraction is that it's inside of a fraction. And in any fraction, the operation that should always be like if I knew what y was, let's say y wasn't a y, it was an actual number. On any fraction, the operation that you should be doing last is always the division. That's what you, if you could do it, that's what you would be doing last. So what ensures that is even though you can't see it, the numerator and denominator are protected by invisible parentheses. So even though you see a subtraction with a 4, as far as PEMDAS goes, that counts as a P for parentheses. So if you were working backwards, that would actually go last. Okay?
You didn't let me answer them.
It's because
I have the
Brian's fault. So that's the reason why I give you that other less formal approach, which is to say, hey, think of it as you're working your way outside in. Between those two numbers, what appears, I mean, it gets to be somewhat a bit of like semantics, and like we're splitting hairs here. But if you were willing to be a little less technical, what would you say is further away from the y, the negative 4 and the 2?
The 2.
Yeah, I would argue the 2 because the 2 is on the denominator. At least the negative 4 is on the same level. They're both in the numerator. The 2 is in the denominator. That's further away. We're going to work our way outside in. What's the opposite of dividing by 2?
Multiply by 2.
Oh, no.
Oh, no.
So multiply both sides by 2. The 2's on the left just cancel.
I know they.
Wait a minute.
Add 4 to both sides like Raquel likes to do. Cassie, you writing all that down? Maybe me.
What's up, man?
Mimi, what would you want to do first here? True, you want to help out your friend? Here's another equation I want to solve.
You want to get rid of the three first?
No.
Don't you do that?
I would, yeah. Like what I would realize here has nothing to do with solving an equation. I would realize that I have a mixed number and they don't really do me any good. So let's convert that to improper. That's the same thing as saying 15 over 2. Now, even though I didn't teach you anything specifically about this, if you were paying attention yesterday, you learned that what you're looking at now is a special type of equation. When you have one fraction equal to another fraction, those types of equations have special names. What's it called when I have just one single fraction? Don't forget the phone.
I have a phone.
What do you mean I have a phone? So if I see it later, I can take it away and keep it if I see it? Okay. I asked a question. I'm still waiting.
Oh, what'd you ask?
You multiply 2.
You multiply 2 on the.
I didn't ask you what to do next. I told you that yesterday, even though we didn't go in depth into this, I introduced you to a new word that is the name of an equation when you have just one fraction on each side of the equal sign. Yes.
Comparison.
We did. It was towards the end. You guys were already kind of distracted. No, it starts with a pro and ends with portion.
No,
proportion. Proportion, yeah, it's called a proportion. Didn't show you how to solve a proportion or anything. Didn't even write it on the board, but it mentioned that when you have one fraction equal to another one, it's called a proportion. And because it's a special type of equation, there's a special way to solve it. I have that special method for solving proportions later on in this slide, but I don't know if we'll get to it. If we don't get to it today, we'll get to it tomorrow. So the approach I would want to take here is just the same approach we've always been taking, which is let's just worry about isolating the x. In order for x to be by itself, I want to get rid of a 3, I want to get rid of a 2. Which one would I get rid of first?
3.
2.
It's just like the other one though.
I know.
Yeah.
And on the one that we just did, I emphasized to you, here, that because the negative was in a fraction, it had that invisible parentheses, so we got rid of the 2 that was further away, that was on the bottom. And then we come back to here. Are we going to get rid of the 2 or the 3? Which one's further away? The 2. So we multiply both sides by 2, and that works out really nicely because not only do the 2's cancel out on the right, they also cancel out on the left.
Oh, snap.
So then, Justin, what we have left is 15 is equal to x plus 3. So what's my last step then, Justin? Justin. Subtract 3 from both sides.
X.
U equals 12.
Oh yeah.
Bro,
Oh yeah.
Any questions there? Whoa, easiest equation ever.
No, it's not.
That must be a mistake because that looks like one that we would have gotten yesterday. Nuha, what would you want to do first here? Right? Because, hey, I see subtraction, and the opposite of subtraction is adding, so we should add, right?
No, we shouldn't. No.
Ashton, do you disagree?
You subtract. Oh, what was it?
I disagree.
Can you subtract?
You add 14.
You subtract 14.
You add 14.
Oh.
No, you subtract it.
You sound like fighting words.
Oh, wait, yeah.
Negative sign in front of it.
No.
Wait, x is a negative.
The x
I realize you see the negative there, the subtraction, but that negative belongs to the x.
Yeah, so you will
You would subtract 14.
Oh.
Okay, yeah, you threw me off, but I still don't get it though. Like, what's different about this than what we did yesterday?
Because you can't. Because there's a negative in front of the x.
Yes, you cannot forget that now when you drop down the x as if it was hot, there was a negative in front of it. So that negative needs to drop down as well. So I don't have, I do not have that x is equal to 5. I have that negative x is equal to 5, but I didn't want to know what negative x was. I want to know what x is, yes.
Can you just put a 1 in front of the x to make it less confusing?
Yes, and then you will.
You think that will make it less confusing?
Yes,
Because you know there's a number there.
Than just telling you, well, I always know that there's a number there.
Some people forget, so might as well put a 1.
and then you multiply -1. Right?
Well, I need to cancel out the negative, and as Claire said, yes, you are. There is a -1 in front, and that -1 is multiplying, right? So how would you get rid of it?
Oh, you divide.
And if you divide, that's fine. I'm not gonna say it's wrong. It's fine. You'll get the right answer. Everybody will live happily ever after, and that's fine. But if you really want to show off and look cool for all your friends, there is a property known as the multiplication property of -1, which states that when I multiply anything by -1, what happens? What happens when you multiply any number by -1?
It's the same.
It's the same.
It becomes negative. The sign flips.
The sign changes. And I don't even like the word flip, to be honest with you. It's changes, sign changes. So, if all I want to do is change that negative to a positive, I'm going to choose to multiply by -1, but it's just more of a preference. If you divide it by any number multiplied by -1 is the exact same thing as if you divide it by -1. So, I get x equals -5. Any questions? Ooh. Karis, any thoughts?
Oh, I know.
I'll pass.
Make it -2y.
What are we trying to accomplish when we solve an equation?
Isolate.
We want to isolate a variable. That's going to be kind of hard to do when there's two variables. So I would like to find a way to put them together. Okay? Besides that, this isn't necessarily something that's a mandate that must be done or else. But what I would highly recommend is if you understand this concept that an equation is just two equivalent expressions. Yeah, equations get solved, but what do we do to expressions? Well, we simplify. We simplify. So what I like to do is before I start worrying about solving and doing things to both sides and canceling things out, let's see if any of the individual expressions can be simplified. That hasn't been the case so far, but here it is the case. I could actually simplify it, as Claire said, by combining what is -y minus y?
2y.
-2y. And now this looks a whole lot like the ones we did before. Troops, what do you want to do next? Good. Tad, what's -1 minus 7? Good. Lorna, what's going to drop on the left? On the left, what's going to drop down? I cancel out the 7. What's going to drop? Yeah, don't forget the negative. -2y. Divide by -2. All the children rejoice because y was full. Last period, I had some kids come up and like do it on the board, but then of course it just got really sloppy. And they actually did them right. They did them correctly on the board, but there's too many distractions. Not necessarily that you have to do it this way, but if you understand that an equation is two equal expressions, and expressions should be simplified when possible, Dane, what would you suggest we do first here? Just want to add. Right. What terms you see that are like?
13. Negative 13.
Good. 5 and negative 13. What is 5 minus 13? They are on the same side of the equal sign. 5 minus 13 is
8.
Negative 8. And now this looks. Okay, so now this starts to look a lot like the rest of the equations we solved. In order to get the b by itself, I have to get rid of the negative 8 and the 3. I would get rid of the negative 8 first by adding 8. 13 plus 8 is 21. Divide both sides by 3. And we get that b is equal to 7. Any questions?
How many of these are there?
Too many.
1,201.
We'll do as many as we can today, and then if we don't finish these today, we'll finish them tomorrow. That's the spirit. Megan, what do you propose we do here? That's what I would do, and that is what I'm going to do, but just so that we're clear, that's not the only thing you can do. Okay? As far as identifying what can be done here, you look at this and say, hey, there's only a single x. In order to get that x by itself, I have to get rid of the 5, the 2, and the negative 3. What appears to be the furthest away? The 5, yeah, I'd say the 5. The 3 is at least inside the parentheses. The 5 is outside of the parentheses. It's not a literal thing where like we're bringing out our measure and bringing out our ruler and measuring how far it is away, but it's just you're working your way outside in, right? So what does the 5 want to do to the x?
Multiply.
Yeah, and that actually is what I'm going to do. I will distribute, okay? But just so that we're clear, what's the opposite of multiplying? If I wanted to get rid of the 5 by dividing, I could. On the left side, it would cancel. And the thing is, the reason why I don't typically do this is because here we're getting lucky. What's 15 divided by 5?
3.
Yeah, 3. Wow, geez, it worked out great. But how about if that number would have been a 14? What would you have ended up with? Yeah, not a decimal.
7. No. A fraction.
Yeah, we don't want that. So, what I would advise you to do to stay away from the boxes, if what we're looking for is some rules that we can follow all the time, let's stick to treating these as separate expressions. I can't do anything with the 15, Lorna, but I can distribute the 5. You okay? It's getting a little boring, repetitive.
I'm dying.
Dave, what do you want to do
You want to add?
next?
Wow, you're on fire today.
Okay, what is that?
Thanks, Mimi. What I asked Dave?
It's David. Deep.
Add 15 to both sides. And then finally divide by 10. Quickly, just to check in on this whole idea of substitution at the end, just so that you see that it still does always work. Now the mystery has been solved, and I know that this unknown number is 3. If I were to plug it back in, what's 2 times 3?
6.
6 minus 3 is?
3.
3. 3 times 5 is?
15.
So I do have a statement. Ooh. Ooh. Okay. Here I see, I'm guessing the first thing that caught your attention is the ugly fractions. But also besides that, we see that there's 2 different ends. I cannot isolate those ends until I bring them together. But actually, for this equation, I'm going to do it 2 different ways. I'm going to solve it here one way, then we're going to go right back to the beginning and solve it again a different way. And it all revolves around the fractions. How can we treat the fractions? This first way, we're going to be brave. And we're not going to be scared of the fractions. Say, okay, if I want to bring the ends together, okay, well, let's bring the fractions together. In order to be able to subtract fractions, I need a common denominator. What is the least common denominator?
8.
Miss Romero, you need to change our seat.
That's not even why.
I'm just thinking of a joke I heard yesterday, and it was especially funny. The end. Elizabeth, what's the LCD of 2 and 16? 16. So I write a 16 on the bottom of then what's that? I'm gonna get halfway through this, and you guys are gonna be like, "Oh, I don't get it." Now listen. On this new line that I just revealed, everything looks the same except for. Okay, fine. You can say the 8n. Now, how did that 8n come about? 2 times what gives you 16?
8.
Shh. 2 times 8 is 16. 8 times that is.
Well, you said 2 times. What is 18?
2 times 8 is 16.
Oh.
Would you guys need visuals?
No. No.
No, you do. Hearing is not enough. So, times 8, right? 2 times 8 is 16. N times 8 is 8. Everything else stayed the same. Now I can bring those 2 fractions together as they've always wanted to be. Maham, the 16 stay the same. What is 8n minus 2n?
6n.
Maham? 6n. Okay. This next step is optional. What do you see again for the second time today and the third time in 2 days, even though it hasn't been written on the board once, but you've been actively listening? So when you see 2 fractions with an equal sign in between,
that's a proportion.
Thank you, it is a proportion, Coda. And there is a special way to solve proportions, but you haven't learned it yet. But what you do know how to do is isolate a variable, so you could multiply by 16 and then divide by 6. That's fine, it'll work, go for it. But if you really want to focus on this idea of keeping the expressions separate and simplifying them, I'm actually not done simplifying on the left. Because what number can I divide both 6 and 16 by?
2.
By 2. I can divide them both by 2. So that works out nicely, not only because the numbers get smaller, but now when I go to isolate the n, the first thing I want to do is multiply by 8. But since I have 8 in both denominators, both of the 8s cancel out. So Sarah, what's gonna drop down? 3n equals
And then it equals 1.
u equal 1.
What whole?
So 3n equals 3, divide by 3, and then yes, Brian, n equals 1. So we got that down, we understand that? Okay, Dane, we'll see how well you understood it, because now I'm gonna come back right at you with the exact same equation. And to test how well you were listening, who remembers what was the first question I asked you the first time we saw this?
What is that?
This is the exact same equation.
No.
And at the very beginning, at the very beginning of this last, when we did it this last time, I asked you a question at the very
Oh, I
beginning.
remember.
What?
You were like, what have we been doing all week?
No.
So then you're gonna show us one.
Okay, and then what did I say right after that? When I actually committed to doing this a certain way, yes, I talked to you about the differences and blah blah blah. But then once we actually started doing this, what was the first question I asked you? What did we do to get from here?
What's the least common multiple?
Thank you. No, not well. Okay, fine. Yes. No, it's actually the same thing. But I actually, yes. What is the least common denominator? And what was the answer to that?
16.
It was 16. Elizabeth answered 16, right? I'm gonna ask you the same question. You're gonna give me the same answer. We're gonna use that number differently. Instead of using that 16 to make the denominators match, that LCD can also be used to start off multiplying everything. Multiply every number by that 16. The good news is if you do it correctly, what that's gonna guarantee you, no more fractions.
Oh my goodness.
The bad news is in order to accomplish that, you're still going to have to work a little bit with fractions because you're going to have to know how to multiply fractions. But once you do it correctly, no more fractions. Yes?
Do we need to use our calculator? Yeah. Are you saying we?
Yeah, from now on it's calculated.
Yeah.
Oh, no, last time.
Because that's what the Algebra I teacher decided. Because that's why. No, the biggest reason, I already told you the biggest reason why we didn't use
Because the
calculators.
calculator gave you the answer for the radical.
Mostly because of the radicals, yeah. Because everything we learned on radicals could be done by a
So why
calculator.
couldn't y'all do like one part of the test calculator and then one part without?
Why couldn't you do that?
Oh,
Because of you.
That's true. All right. So now let's multiply. Okay. 16 times n is
16
divided by 2.
8n.
8n. Okay. Here for the next one, because I gotta distribute, the 16s cancel out. So really, you're just left with
2n.
negative 2n. Okay. And on this one, you can do 16 times 3 and then divide by 8, or I like to divide 16 by 8 first, which gives me 2. 16 divided by 8 is 2. 2 times 3 is 6. So before you freak out, this is just like a really complicated way of just showing you exactly what I just did verbally. What did I end up with? 8n minus 2n equals 6.
Okay, that's easy.
If you don't want to write that second line, don't. That's just showing you by reducing what I ended up with. More importantly, what didn't I end up with?
A fraction.
No more fractions. Yay.
I like that way better.
Yay, Brian. Well, I used to only show it the first way, but then I feel like more and more kids started coming into my classes knowing how to cancel out the fractions, so I kind of gave in. And I think more teachers are starting to teach it this way, showing kids how to cancel out fractions through the testing. 8n minus 2n is 6n divided by 6. Is the really nice thing about this is that even though we did it 2 different ways, what did we end up with at the end? Same solution. Same solution. I.
Did you just say I?
I've been taking cool lessons.
Why would you just do that?
All right. I'm gonna skip this one. This is just it's the same thing we were doing with decimals. What you need to start learning to equate, no pun intended, but to equate decimals with is the calculator. The only skill you would need for this versus the other ones would be a calculator. What did I do first if you're just looking at this as a whole? I subtracted 1.12. Okay, you might need a calculator for that. What did I do at the end? What was my last step? Divide by 1.25. You would just need a calculator for it. That's the only thing that's really different. I want to get to the more important ones.
Wait.
Where can we find all these?
Online.
Why do I have to go online?
Well, because this so we can get through all of these.
So have you seen the class once like you do it online?
Why do I have to? You do it. You do it for me. I don't want to do it. You do it.
I do it.
Right. But I don't want to go online, mommy.
Yes, sir. Very funny.
Thanks. Megan, what's different about this one? Say it better. I like what your eyes are looking at.
I know.
Oh.
The variable.
No.
Bro, Ryan, that's your girl.
Julius, go.
The variable.
What about the variable?
It's on both sides.
Yeah, we have variables on both sides.
You have to move one to the other side.
So, if you understand that what we're trying to do is isolate the variable, that variable will never be isolated if it remains on both sides. But we have to put them together.
Oh.
Okay.
That's bad.
Thanks, man.
That's going to end up as a negative.
There is no rule that says variables have to always end up on the left. You can put them on whatever side. My recommendation to you, you know how I like to make things harder for you. I like to move the smaller coefficient. Because really what that's going to guarantee you, anytime you move a smaller coefficient, it guarantees you end up with a positive in front of the variable, or a positive coefficient. It's one less thing for you to make a mistake on. So, way too many kids like to focus on the constants first. They focus on the -1 and the 15. No. When I get an equation, I focus on the variables. So, you're right, we have different sides. This first one has a 5 in front. Here we have a 1 in front. What's smaller? The 1. So, not because I have to, but because I want to, I'm going to choose to cancel this out so that it will reappear on the other side by subtracting x on both sides. That's what I'm going to do first. If you have solved these equations before, I can almost guarantee you that what your teachers have taught you is to now combine like terms. Before the x's were on different sides, they could not be combined, but now they are on the same side and they can be combined, and if you want to combine them, be my guest. That's fine. There's nothing wrong with it. What is 5x minus x? 4x. Drop down the -1, drop down the equal sign, drop down the 15, and then keep on solving. But what I would propose to you is, well, if I'm going to end up doing the same step after that, might as well just do it now. And what that step is say, okay, I've tried to compare that equal sign to being a wall. And remember, all x wants is to be alone. Mommy, I'm a grown-up. I want to be a big kid. I want to be able to stay out after midnight. So in order to be alone, any term that doesn't have an x needs to go bye-bye on that side. So the x's have taken over the left side of the equation. Who doesn't have an x there on the left side? The negative one. How do I get rid of that? So whether you wait one more step to do it, or you do it now, I'm going to do the same thing anyway, so you might as well just do it now and add 1 to both sides. But I don't get it. I'm so confused. Okay, then don't do it this way. I'll put it to you one more way. How many terms did I start off with on the equation? In the entire equation? 4. How many terms do I still have? 4. Those crosses mean they're gone. They're not there anymore. I now have 4. They're just on the correct side. 5x minus x is still 4x. 15 plus 1 is 16.
Divided by 4.
Divide both sides by 4. So x equals 4.
Is that all of it?
Ooh, it's a lot of g's there. If an equation is just two equal expressions, the first thing I would like to do is simplify the expression. An expression cannot be in simplest form if it has a parenthesis. There has to be a way to get rid of it. Bryce is thinking long and hard as to how he can get rid of that parenthesis. So go ahead, Bryce. Drop it on us. How do we get rid of that parenthesis? Say it again? Okay, good enough. That's fine. I'll take that. Distribute the one on the outside. Anything times 1 is itself, so every term drops as if it was half or without the parentheses. Tad, what do you want to do next? Combine what? Which ones? G minus 3G. What is G minus 3G? G minus 3G.
That's 2G.
Negative 2G. So I have a negative 2G. Oops. I have a negative 2G plus a 4. Okay. Well, now, after these two extra steps, this equation has become like the last one I just did. I need to put the g's on the same side. Not because you have to, but I recommend to move the smaller coefficient. What number is smaller, negative 2 or positive 1? Negative 2. So I'm going to add 2g to both sides. Not because I have to, but I'm trying to avoid a negative. So I get to here. The g's have now moved over to the right. And they're like, we taking over. One term at a time. Who are they going to cancel out? Who doesn't belong there anymore?
The 1. The 1.
The 1, thank you. The g's moves over to the right. That one can't be there, so minus 1 on both sides. I started with 4 terms. I still have 4 terms, but now they're just like 4 minus 1 is g plus 2g is 3g. Divide by 3, g is 1. Hang in there, Claire. I will do one more. He gonna do one more. He gonna do one more.
There's no solution.
Did we get past the other
You're supposed to. I'm starting to worry now that I might be my girlfriend.
Did we get past it?
Oh yeah. Oh yes, you got past the process. Variables again on both sides, right? So I want to move them together. There's something I can simplify. But now when I go looking at this is why I told you look at the variables first. Look at the variables first. When I look at the variables, they both have the same number in front. So regardless of which n you want to move, you end up doing plus n on both sides, and all the n's cancel out. What are we trying to do to an equation? Solve. What are we trying to solve for? The variables. Oops. I don't have a variable anymore. All the variables cancel. So here's what we learn is if and when all the variables cancel, drop. No, you can't assume that. We drop the leftovers. And now, okay, I'll wait. We now have a statement of equality that says that the number negative 24 is the same as the number 5. Is that true?
No.
Because it's false, that's why there's no solution. That's a symbol for no solution. It's called the empty set.